Today you are going to learn about functions and the domain of a function. So a function is a line that goes from left to right, but it's not going to go from left to right to left to right in zigzag. Okay, so this line here, it goes from left to right, keeps on going. This one, it goes from the left and it's still going to the right as it goes down and then up again. And this one is going from left to right as it changes height, but that's okay because it's still going from left to right. All right, so for this one here, these are not functions. This one goes from left to left again. That can't happen. And then this one goes from left to right to left to right. That one is not a function. Another way to tell too is if you were to draw a line, a vertical line, this vertical line would only pass through the graphed line at one point, no matter where you draw that line. So I'm going to actually go back to these ones here. So if I draw a vertical line, let's say here, it's only going to pass through the line once. If I draw a line here, it only passes through that line once. Okay, if I went to these that are not a function and I drew a line, let's say here, that passes through it 1, 2, 3 times, and that's not okay. All right, sometimes we're not given an actual graph, we might just have a table. So in our table, it is a function if each value of x appears only one time. If a number appears in the x column more than once, so 1 and 1, 2 and 2, it is not a function. Because if we have 2 points, so 2, 8, so we'd go over 2 up to 8, and then if we also went over to 2 up to 7, and we drew that vertical line, it would pass through it 2 times, which is not okay. All right, an easy way to remember that table trick, think of the X column as dollar bills that you have, and you're putting them into a vending machine to choose an item. I can put my first dollar in one time and only one time, okay? My second dollar bill, I can only put it in once, okay? I can put in as many bills as I want to. I can get the same thing from the vending machine. So like I can get the Lay's potato chips with my first dollar, and I can get them again with my $8. But I cannot put in the same dollar bill. So you absolutely cannot see anything that repeats in the X column. All right, next up is the domain of a function. The domain is all of the possible X values. So like all of the possible values in the X column of a table. Okay, so, oops, where'd those go? All right, so I have a point here, which is at -2, -2. I have a point at -1, -1. So all of these points along here, ranging from -2 to +4. And these are closed dots at the end, which means it could include those numbers, okay? So our X is in between -2 and +4. It also, though, could be, let's say, maybe -1.5 could also be another value of X. It doesn't always have to be at an intersection. There's a whole bunch of points all the way along this line. All right, so for this one, our X value has to be between -6 and +5. However, since these are open circles, it cannot be equal to those numbers. So I did not put that underline here because it cannot be equal to those numbers. So that means we could have maybe a point here at -5.99 or over here at 4.99, but we can't have a point at exactly 5. All right, so for this one, our smallest X value could be -2, and it's a closed circle, so it could be That's not working appropriately. And then for positive 2, it can't be exactly equal to it. It can be super, super close. Okay. There's also one in your classwork today that actually has an arrow instead of a dot. So that means it's going to go on forever and ever and ever in one direction. So for that type of one, it would be x has to be less than 2. So it could be a 1, it could be a 0, it could be a -1, it could be a -10. Whoa, I don't know what just happened there. That was weird. I don't know how I zoomed in that far. Okay, so if it goes on forever and ever and ever, then it would just be like x is less than some number or x is greater than some number.